This is the last part of our video about trigonometric substitutions. This time we're going to consider a more complicated problem. No? As you can see, the expression inside the square root is does not satisfy any of the form for our table of trigonometric substitution because you have x squared plus 2x plus 5, so none of this form is satisfied. But there's actually a way to convert it into that form, because actually we can write this as u squared, no? Where u is a function of x, this one also as u squared. So therefore that means that your u is a sine theta, u is a tangent theta, and u is equal to a secant theta. In other words, we're writing here the more general form of the trigonometric substitution. So that's what we're going to do here. Okay, how do we write this in one of these forms? A squared minus u squared, a squared plus u squared, x squared, sorry, it should be u squared minus a squared. What I'm going to do here is to convert this into one of the form, no, in our table for trigonometric substitution. I'm going to use completing the square here, okay? So that we'll be able to write this as square root of u squared plus something or minus something, okay? So let's do that. Integral of dx over square root of x squared plus 2x. Now I can separate this 5 here so that I'm free to provide an expression here so that this will become a complete square. What should be added to this to become a perfect square? It's actually 1, no? It's actually 1, because this one will become x plus 1 quantity squared. Since we added 1, that means that we subtract also 1 here, okay? So it is as if we just added 0 to the whole expression. And then this one will become dx over square root of this will become x plus 1 quantity squared, then plus 4. So obviously this is your u. It is of the form u squared plus 4. So going back to our table, it satisfies this form, right? That means that our substitution is x equals a tangent theta. Okay? Well, let's solve that directly without using the diagram anymore, the right triangle. So your u is equal to x plus 1. Okay? That means that x plus 1 is equal to, from our substitution, u is equal to a tangent theta, where your a is 2, right? Okay. So basically we have the form square root of a squared plus u squared, and then the identity or the substitution is u equals a tangent theta, and your u is x plus 1, so that means that x plus 1 is equal to a, which is 2 squared or 2, so 2 tangent theta. Okay, then we're going to find for dx, because we have dx here. So what is dx? Derivative of this is dx. This is 2. What is the derivative of tangent? That's a secant squared theta d theta. Another thing is we want an expression for this. So what is the square root of x plus 1 squared plus 4? Okay, that's actually equal to, your x plus 1 is 2 tangent theta, so this will become 4 tangent squared theta, then plus 4. Again, 4 is common, square root of that is 2, so you have tangent squared theta plus 1. And the identity is, this is secant squared, right? And the square root of that is secant theta. Okay, so let's now continue. So this is the integral of dx, which is 2 secant squared theta d theta over square root of x plus 1 squared plus 4 is 2 secant theta. Okay? And we have the integral of you cancel this, so you have secant theta d theta, right? Okay, which is equal to, if I'm not mistaken, the integral of this is ln of the absolute value of secant theta plus tangent theta, please check, I'm not sure, plus c equals, so we're almost done, except that it should be expressed in terms of x. Okay, now what is secant? What is secant theta? Secant theta is square root of x plus 1 squared plus 4 over 2. Okay, so you have square root of x plus 1 squared plus 4 over 2 plus tangent theta. Tangent theta is x plus 1 equals to tangent theta, so that means that tangent theta is x plus 1 over 2, x plus 1 over 2, then plus c. Okay, or you can express your final answer as ln of the absolute value of the square root of x squared plus 2x plus 5, then plus x plus 1 over 2 plus c. Okay, thank you for listening and watching.